Welcome in, students. I'm videotaping this from the gym that I work out in Columbus, Ohio. So today we're going to explore a little bit about positive relationships, or when two pieces of information both increase. So we're going to explore about functions. So function is something that has to make sense. It has to work. So in math, that means that it has to equal out. So if you have a problem that you're solving when you're dealing with functions, whatever piece of information you use, they both have to equal at the end of your equation. So we're going to start off with an exercise called the deadlift. But first we're going to explore this piece right here. This is an Olympic bar. So this already has a starting weight. So in this example, this has a starting weight of 45 pounds. So in this exercise, the goal is to take it, lift up, and bend down. Simple as that. So thinking, this is the starting weight of 45 pounds. How would that show up in a linear function? Here you can see we're starting off with one on each side, but our goal is to count how many total we have. Because ideally you want the weights to be balanced so it's not offset. So you have to have an equal amount on both sides. This is just a tip for safe exercising. In this example, we have two 45-pound plates total, and then we have the bars. So how many bars are there? You have to think about that. The piece of equipment that I'm handling. So there's only one. So no matter how many plates we put on here, this piece of information right here never changes. So this is what you would call the y-intercept or the initial value. So if you were graphing how many plates you have and the total weight, this already starts at 45 pounds. This doesn't start at 0. Even if we take the plates off, we still have this piece here which always weighs 45 pounds. So now we have the two plates total. So how much weight do we have total? So in this example, you can count up. We still have the starting weight right here. This always starts at 45. So that's a one-time piece of information we always add. Then you have to think of the variable. Each plate we know weighs 45 pounds, so that's a number that never changes as well. In this example, we just happen to have, we're adding 45 always because of this weight, and then each plate is 45. So that's just a coincidence that we're using that number two different times. Now the very first variable is the input. How many of these do we have? We know that each piece is 45, so how many do we have total? So you keep that number. Then you multiply the number of these we have by the weight of each one. We add this last piece of information we found here, and we get our total weight. So this is the deadlift, and I'm going to show you quickly how you can work through this. So the goal is to bend down and stay as close as you can to the floor, and then you want to keep your back straight, strong hands, and then you just simply lift up. And so this is called a deadlift because the weight is at a dead stop, and you go from that, lifting all the way up. So we're going to go one more round, and if you can see, how many do we have on this side, how many do we have on this side when we come to the 45-pound plates. And think that is your variable. So you change that number, so how many do you have total? You're going to multiply that by what we found to be the slope or the constant rate of change. How much are we adding in this positive relationship? So how much are we adding each time when we add one plate? So that is our unit rate or our slope. Then we can't forget this piece here that I'm grabbing onto. This has a certain weight. And then that gives you a total weight or total poundage. So your goal is to determine how much total weight this last exercise was done with. So here we go. Again, keep your back flat, hands are nice and tight, and breathe nice and smoothly throughout. So that is the deadlift. So your goal is to determine how much weight was used as we understand this function. So you have to have a number that goes in to our equation. You have to figure out what the piece of information we're using are, and figure out what the total weight is. So as the number of plates increases, does our total weight increase? And ideally, you want to think if both pieces of information are increasing in value, or the numbers are increasing, that would be a positive relationship or positive function. Thanks for joining me at the gym today.